Yes, hello everyone. In my talk, I would like to give you an overview on the seismotectonic setting of the South Aegean region. And this is done especially in the light of the current seismic crisis near Santorini. This is a collaboration together with my colleagues Thanasis Ganas from the National Observatory of Athens, Patricia Martinez-Garçon from GFZ and RWTH Aachen, and Margarita Sigou from the British Geological Survey. The outline of my talk, I will start with a very brief overview of the geodynamic setting of the region, then briefly refer to historic volcano eruptions, earthquakes, and tsunamis. And then I'll focus on the central Hellenic volcanic arc and give you an update on what we know and eventually don't know, and will then move on to a brief recap of the current seismic crisis, reporting on first observations and results, and I'll end with some conclusions. Now, what you see here is the Hellenic subduction zone around Crete and the Hellenic volcanic arc. And the crustal structure was first derived by a wide-angle seismic experiment that was conducted in the late 1990s. And that revealed that there is actually a rather thick continental crust below Crete, about 30 kilometers. And then it was also possible to image the slab of the African oceanic lithosphere that is going down towards the north-northeast. And what you see on the left-hand side, the blue line here is the coastline of Crete, and then the slab at depth. And if we move this towards a three-dimensional image, we're coming up with a sort of amphitheatric shape of the subduction zone. And that results in a total of 4 volcanic centers. That's called the Hellenic volcanic arc, with Santorini at its center. And this will play the main point in this talk. And that's a photo, or basically it's an image of the Santorini caldera that is on the northern tip of this profile here, and is located, as I said, at the central Hellenic volcanic arc, where the slab is at a depth of about 120 or so kilometers. Now, Santorini was created during the so-called Minoan eruption about 3,500 years ago, and that resulted in a huge event with ash being distributed throughout the eastern Mediterranean region, and it likely also contributed to the extinct of the Minoan culture. So the island of Santorini, or the island group, was basically created back then, but is now growing again. What you see here is a vertical uplift during several years, which indicates that the center of the island has highest rates of increasing altitude, and that's also where the volcanic center of the island is. And looking at an aerial photograph here shows an almost perfect caldera, and at the center you see Nea Kamenni, which is the current center where eruptions have been reported and even photographed basically a century back in 1925, 26, and then also in 28. Now this white stuff, what you see here, that's probably something you pretty often see at rocky islands in the sea, which is created by lots of birds, but this is actually different. So here on Santorini, this is civilization. So this is settlements at the crater rim, and this of course poses some substantial hazard, or poses some risk. But it also is a source for really, really scenic views, which is why this island is so touristic. And that also is the reason why it currently receives so much attention. Now, one more slide on Santorini. So it's a dynamic system. And interestingly, over the last 20 or so years, the highest elevation rates, or the highest increase in elevation, has been towards the northeast of the island, which is where the submarine Colombo volcano sits, about 7 to 10 kilometers northeast of Santorini. But if we look at the recent records of the GNSS data from there, we see an accelerated movement that already start about half a year back from now. And this has been further accelerated during February. Now, keep this in mind. First, a few more slides on historic events. So there has been a mega earthquake on Crete, and with a resulting tsunami that, in fact, to all we know today, has not been a subduction megathrust event. But it happened in the upper crust. The magnitude was about 8, and it resulted in an up to 9-meter uplift on western Crete. There was a regional tsunami, and you see the wave heights here. So that's a scenario that certainly has to be taken into consideration for tsunami early warning, which is currently being built up for the Mediterranean Sea. There also has been a notable earthquake in the Hellenic volcanic arc, the 1956 Amorgos earthquake, actually 2 earthquakes that occurred within 30 minutes. And at least one of them has created a local tsunami where you see the wave heights reached more than 20 meters on Amorgos. So this was clearly a very relevant event, but a local event. But if such an earthquake would happen today, of course, there would be substantial implications, given the fact that there are millions of tourists in this region during summertime. Now let's focus on the central Hellenic volcanic arc. What you see here is the seismicity in the region observed during 40 years by the NOAA permanent network with 4 stations in the region. And it basically shows pronounced activity along the Santorini Amorgos region, and then a few dots here and there throughout the larger area. Now, to have a much more detailed picture of the seismicity, we had installed a so-called seismic network with 26 stations on 17 islands back in 2002. And this was in operation for a bit more than 2 years and resulted in a much more detailed picture. Now, this network was sponsored by the SFB 526 Rheology of the Earth, at that time located at Ruhr University Bochum. Now, looking at the seismicity from SeisMet, we see a much more detailed picture, and I won't go into too much detail here. There's some seismicity clearly related to the occurrence of islands, even on islands where there was no station, so that's not a station artifact. But most importantly, let's focus on the region between Santorini and Amorgos, where there is pronounced activity. Almost no activity below the Santorini volcano, but then pronounced activity right below the Colombo volcano, and then a bunch of activity further towards the northeast, just southwest of Amorgos. And the question is, of course, what can this be? Before we look in more detail, let's have a look at the geodetic data. Putting the GPS data in a local reference frame, we see that this region between Santorini and Amorgos is clearly a transtensional feature with slow but notable internal deformation. So that's a right lateral dextral transtensional zone. And that also fits very nicely with the focal mechanisms shown here and more than that were reported later. And actually, that's also what we see mostly in the current seismic activity. Now, looking in more detail into the seismic cloud that I had mentioned, we relocated those events back then with HypoDD, and we found that these are actually individual locally focused seismicity streaks. And the model derived from this was that this is eventually evolving volcanism where there is no active volcanism yet, but this might be something under development. And this is exactly the region where the current seismic crisis is taking place. Now, one more word on the Santorini seismic crisis back in 2011-12. There was a swarm activity for several months, and looking at the activity below Santorini, this actually reached a depth of only 1 to 2 kilometers. So at that time, probably the system was very close to an eruption, but then went down back to sleep, and there was almost no activity after that. Now, let's move to the current seismic crisis that is occurring, as I said, right between Santorini and Amorgos, mainly not below the Santorini volcano and also not directly below the Colombo volcano, but it's basically activating all the area below the island of Anidros, southwest of Amorgos. And what you see in the lower right is the histogram that is starting early February, when it took lots of attention in media and of course also by the local authorities, because activity was strongly increasing. But if we look then at the current picture, we see, and that was also the most likely scenario that was postulated by GFZ at that time, that the activity would eventually slowly going down. And this is what we see right now, with very few magnitude larger than 4 earthquakes during last days. On Monday, there were 2 such events, but otherwise activity went down after February 14. However, on February 14, there was an interesting change, which actually indicates that the system is highly dynamic. So there was what we would call the Colombo swarm. So activity went towards Colombo and had a strong burst of activity for a couple of hours. And then this actually also coincided with a substantial change in the geodetic movement, so with lateral deformation and also vertical deformation. What you see here is the island of Ios, and that's the island of Anidros, where a GNSS station was put up about 2 weeks ago. And this shows a pretty accelerated movement with several millimeters of deformation per day. And again, that indicates that the system is highly dynamic. This Colombo swarm then stopped after a couple of hours, and in general, the seismic activity went down since then. A few updates from ongoing research and studies we do with that data. So if we look at the focal mechanism on the lower right here, blue are the p-axis, red are the t-axis. That exactly shows what we would have expected. So it's transtensional, normal, and strike-slip faulting. This is in line with the current understanding of the seismotectonic setting. We did apply conventional methods. We also applied gamma FaceNet to derive a high precision, low detection threshold monitoring network catalog. So this gives us more than 30,000 events, which we're currently relocating and working on to get a much more detailed picture on the activity. Last but not least, I would like to show you the Hudson plot. So we calculated moment tensors, and what we see is pretty interesting in that we have a couple of events that have mostly DC, so double couple source mechanism. We don't see any clear volumetric components, but we do see strong CLVD. And that would support the model that the activity that we're seeing is actually volcano seismic activity. So representing magma that creates a pathway to either fill a magma chamber or to move further upwards. At present, to all we know, the activity is mainly focused around, say, 5, 8 to 12 kilometers. So a few kilometers away from the seafloor, which would indicate that we're not really close to an imminent eruption. Last, I would like to show you some fascinating waveforms. So this is a bunch of data, actually 2 examples from some of the events, and there's lots of in it. So many small events. We will investigate whether we do observe foreshock sequences here, which would allow contributing to a sort of forecasting system. But we also see in the lower plot here interesting broadband recordings, which might indicate a static offset of the islands, which of course we will correlate soon with GNSS data. Now this brings me to summary and conclusions. The central Hellenic volcanic arc between Santorini and Amorgos is a right lateral crustal zone of weakness, with little internal deformation providing pathways for upward migrating fluids and magma from the slab at about 120 kilometer depth. The current seismic crisis fits well in this setting, with at this point predominant seismicity northeast of the submarine Colombo volcano and southeast of Amorgos. This is eventually indicating developing juvenile volcanic centers there. There is strong dynamics in both space-time evolution of seismicity and surface deformation of the islands. This needs to be monitored with high resolution and in real time. The most likely scenario is that the seismicity further decays. A larger earthquake in the region can occur anytime, but there's no direct indication at this point in time. Should magma migrate to shallower depth, an eruption would become more likely, both a large earthquake and a submarine eruption would have the potential to generate a tsunami. And with this, I would like to end my talk, and I thank you for your attention.